I did a live demo of this for the Trident Pinball Discord, and I figured I should have a recorded version as well. So in this video, I'm going to give you a basic rundown of how to model a bent sheet metal ramp. There are a couple of styles, but the one that I'm going to do is where the floor and the walls are separate and are bent and then combined with tabs. So anyways, let's get started here. There's probably a few ways to do this, but the biggest challenge when using a sheet metal model, which is this tool here, the biggest challenge is that you can't use the standard extrusion operations except remove. So some of this process is going to be designed to kind of get around that limitation and to show you how to kind of end up with something that's flexible and useful, but still remains a sheet metal model. So the approach that I like to go about doing this is to create two sketches. One is going to be our outline. So if we were looking top down at the ramp, that's what we would see. And the other is the profile, which is if we were looking at the side. So the profile will describe our incline, our slope, and then the outline will describe our shape. So let's go ahead and start that. So I'm just going to create a new sketch here on the top plane. And if you were laying this out for an entire game, like you had modeled your entire playfield, one of the things you'd want to do is you'd want to sample off the flippers and make sure that your entry angle looks good. However, I'm just going to show you modeling this, so I'm going to skip that part. But typically what I would do is I would start with the entrance, and so I'll just do a midpoint line here. That's way too big. Let's give our entrance a size of 1.2 inches. Okay, now from that, we can then draw some lines that come off of it, and I'm going to give it a slight taper here. Yep, okay, looking good. All right, so this is pretty standard fare so far, and for this ramp, a very common arrangement is that the ramp curves around, kind of does a 180 either to the left or the right. So let's go ahead and model going around to the 180. Now there's a few ways to do this, and early on when I was using OnShape, I used this spline tool a lot. And so spline, you kind of click out these points. The challenge with spline is that it produces, it's sometimes hard to control for one, but even more so, the big thing to know about spline is that OnShape does not recognize it as a cylindrical surface. And why that is important is later on, if you want to add bendable tabs to your model, you will probably end up using a tool over here called wrap, and wrap requires that you have a cylindrical face. So the solution to that is pretty much to stop using spline and instead use this one here called 3-point arc. The way that 3-point arc works, I'll do a demo off here to the side and then we'll do the real thing, is you have to place 3 points. The first point is the start of your arc. The second point is the end of your arc, and I'm clicking each time I do this. And then the third point is you're defining this radius or flex of the arc. Now, one of the things about this tool you can see as I get close over here, it wants to snap. You see how that wants to snap there? So we can use that to our advantage. So I'm going to select 3-point arc, and I'm going to make this ramp curve to the right. So I'm going to start on the right wall. So that means I'm gonna connect with this, and I'm gonna bring it over here, and I'm just gonna eyeball, like let's say we go about there. Now that snapping behavior, when you connect to an existing line, one of the things it will do is it will give you a coincident constraint. So there you can see it's telling me right there is gonna be a perfect transition from my sidewall into this turnaround. So I'll go ahead and accept that. And then let me do one more, same thing. So I'm just going to click over here, look for the constraint, and then we're good. Okay, so I want to add a few more constraints. Let's go ahead and finish this. Let's give that a fixed size. So that was a good guess. I was going to make it 1.4, and I got pretty close. So that's nice. And then over here, let's just constrain. We'll just constrain that to 1.5 to make sure that this is very comfortable for the ball to pass through. So at this point, depending on what we were trying to achieve, this actually might be sufficient. In your use case, you may want to dimension some of the angles here. So for example, maybe you want that exactly at 87 so that it's a little straighter. The other thing, of course, to be concerned about is this, that exit there. So depending on how you have this set up, maybe you want to dimension that, you know the angle that's coming off of that. So for example, maybe I want to set that to 165. That's a little wonky. You know, so maybe this is a little bit more the shape that I care about. And then of course, lastly, maybe you care about this approach length. So maybe I want to make that a little bit more. Wow, that just weirded out, didn't it? Okay, we're going to have to fix that. I'm going to undo some of that. That probably would have been smarter to do that ahead of time, but I'm not going to redo all of this. Okay, so we've got our basic shape here, kind of set out. And remember, we're only trying to describe what the ramp looks like from the top. So I'm going to accept that, and just to keep things tidy and organized, I'll go ahead and name that. Now, the next thing that I want to do is I want to create a sketch that is going to describe the slope or the rise or the incline of our ramp. And so in order to do that, the easiest way that I have found is, in fact, to come back here to this outline, and I'm going to make a construction line. Okay, and so in this case, you saw I used the center line of the ramp entrance, and I just drew a perpendicular line off of it, and I made it a construction line. And the reason why is because now I can use that, and if I go to plane and line angle, I can select that, and you can see it's flat, but I'll put in 90 degrees there. And so now I have a plane that basically bisects the entrance to my ramp, and I can use that plane to sketch our outline on. So I'm going to start by just eyeballing this a little bit. So maybe I'll do something like that. Now, I started by, you can see here, I'm sampling, I've locked my starting of the slope to the beginning of our ramp, which is right there. However, I want to make sure that I draw the entire side profile. So what I'm going to do is I'm going to say use, and I'm going to use effectively the line that projects to how far our ramp comes out. Great. And then from there, I'm going to draw a perpendicular line up. And this is just going to make sure that our profile here matches. Okay, so that's looking good. We can also use the height of this line to set the height of our ramp. So maybe we want our ramp to come up 1.75, or maybe we want it to come up 2 inches or whatever. Great, we can set that there. Another thing that we can do is typically we wouldn't want our ramp to just go straight into like a sharp point here like this. We would want it to be a smoother transition. This, of course, is a bend that we would have to do when we're making our ramp, but we can add that in using the sketch fillet tool. So, you know, actually a 3-inch fillet there looks pretty good. Okay, so now we've got a smoother transition. And then the last thing to be mindful of here is when we bend this, you know, during the manufacturing process, we're going to have to hand bend this, and we can probably only bend the part that doesn't have this return kind of sticking out. So we want to know where our return finishes. So there you can see I projected that dot out to here. And the reason why is that now we can make sure that we're giving ourselves enough working room. So I'll say 1/2 inch. And what this does is when we actually go to bend this for real, it just means that we're leaving ourselves a 1/2 inch, that we're not going to accidentally bend this part back here. Okay, cool. So just to recap here, we've done 2 things. We drew an outline, so that's what our ramp is going to look like from the top down, and we drew the profile, which is what it's going to look like from the side. And I'm going to name that profile. Okay, great. And now we're actually ready to turn this into 3-dimension. So I'm going to go over here to sheet metal, because of course we're going to make this out of sheet metal. And I'm going to choose extrude, and then I'm going to pick our profile. So instantly what happens is you see we kind of start to get something here. And obviously that's not wide enough. I'm going to change this to symmetric so that it centers in our line and moves in both directions. And then I'm going to make it large, because what we're going to do is we're going to use our outline to then define the portion of the sheet metal that we want to keep. The reason, by the way, that we're doing this is because of that limitation that I mentioned, where you can only perform a remove. Technically, there's a tool called a tab, and a tab would have allowed us to add this part over here, but I find it's easier to just model the entire thing as one outline and then perform a remove on it. So we want to stretch out our sheet metal so that it's effectively big enough to fit that. So I'm just going to type in 10 inches. That's good. Okay. So this is looking good. The last thing we want to do is we want to remove the portion of our sheet metal that we don't want to keep. Now, this is why there's two sketches, is because you can see with sketch number 1, we defined how this sheet is going to rise, the slope of it. And we're going to use the second sketch. So I'm going to create a new sketch on top of our sheet metal. I'm going to use the Use tool. I'm going to select our 3 regions of our sheet metal, and then I'm going to pick our part below. Now, what this does is this gives me all of the negative regions. So I can choose all of those, and I can perform a remove through all. And let me turn off the original outline. What we're left with is a sheet metal model that has our profile and has our shape. And the cool thing is, if we want to make adjustments, we can go back. So let's say that I change my mind and I want to make that a little bit more narrow. I want to make it 1.3 inches, or maybe even I want to make it 1 1/4 inches. I can do that. And now the whole thing updates. I've got one place that I can edit the shape, and I've got one place that I can edit the slope or the rise, the profile. Okay, cool. So that's, of course, the first part. So I'm going to name this. I'm going to name this floor. Okay, so before we move on, there is one last thing that I want to make mention of here. If I turn these planes back on and we look at the profile, one thing we can see is that the sheet metal here is, in fact, it's going below the plane that we started on. And the reason for that is when we create a new sheet metal model, there's a few details over here that matter, which I'll touch on here now. One of those details, of course, is the thickness. And because I use SendCutSend a lot, SendCutSend, my thickness is set to typically what I use, which is 0.6. But say, for example, you were going to use a different thickness, you could type that in here. And so then you can see it adjusts. Let me change that back. Whoops, that was too much. The other thing is, you see next to this thickness, there is an arrow. And what this arrow does, you can see the difference there. It toggles which side of the line the sheet metal is going to be rendered on. And so in this case, we want our sheet metal to sit on top of our playfield. Usually that's how it goes. And so I want it to render on that side of the line. If you were using CNC to cut out your playfield and you wanted the sheet metal to sit slightly below, you could do that and potentially avoid the need for a flap here. So I just wanted to point that out. The option's up to you. I'm gonna leave it the traditional way, which is the way that typically requires a flap. Anyways, okay, so there's part 1, which is drawing the floor. All right, so let's work on the walls. So this is where drawing an outline helps. You will see why. Because you would think that what you could do is that you could just say extrude, and then you could just choose this line here, and the wall would follow it like a sweep. That would be so much more convenient, but unfortunately OnShape doesn't seem to support that. So the way that I have found around this is, you see that I brought back our outline, and what I can do is I can create a wall. I can create a wall there, and of course this is another case where the alignment of the wall matters. So you either put your wall on top of your floor and then cut out the portion that you don't want, or you put your wall outside your floor and you're going to have to add tabs on the bottom where it connects. Either way is fine. The choice is up to you. I'm going to put my wall, you know what, I'll put it on the outside. Okay, so I've got my wall there, and as you can see, it's not high enough, so we need to know something here. Before we continue on, we need to know how high our ramp comes up. So we go back here to our profile, you can see I've got this value. This is the height of our ramp. What I'm going to do is I'm going to create a variable for that. So we'll call this ramp height, and I'll say 2 inches. Now here's a key, is that variables have to be defined before you can use them, so I typically just always drag them up to the top. I'm going to go back to profile here, and I'm going to edit this so that we're going to use that variable. Okay, there we are. And now here, when we are defining this, I can use that variable as well. So using ramp height, you can see it will bring us up to right on the bottom here of where our ramp is. And we've got our metal thickness. So I'll say 0.06 inches. And now you can see it's coming up so that it's the same height. And then on top of this, whatever we want to add for our wall up here, we can. So I'll just go with 1 inch. Okay, that's great. And let me do that again for the other side. Boom, boom, boom. And I'll do the same thing. Ramp height plus metal thickness plus the wall height gives us our wall. And what did I do there? I selected something I should not have. So I do not want that line to be a part of it. All right, there we go. That looks good. Okay, looking great. I'm going to adjust the appearance of those real quick. So now we want to, obviously that's not how the wall should go. What we want to do is we want to then cut out the region here that will be the portion of the wall that we want to keep. Because remember, the limitation here is we can only remove, we cannot add. So I'm going to create a new sketch. I'm going to project both of those there. I'm going to turn off that area. And then I'm going to project all of this geometry here. I'll turn it back on. And so, oh, I messed up. Let me try that again. I missed this part here. So I projected that center dot instead of projecting the line. Anyways, so it gives us that region there. And this isn't going to be our final, but let me just show you what we're going to do with this. So now that we have this, what I'm going to do is I'm going to fill it in. So I'm just going to connect that line there. And I'm going to connect to this bottom line here. And I'm going to connect the top line here. So now we've got these regions all the way filled in, and you can see here if I perform a remove operation. Whoa, okay. So you see how it deleted that entire area? So the part on the left looks good, the part on the right doesn't look good. What happens if this happens to you? It means that that line is not completed. So let's take a look here. So we're looking for the section that is not completed. I bet it's down here. Yeah. So see how we had this little gap here? So I am going to finish that off by connecting it. And now we will perform a remove. I'll say through all. And so there you can see, at least on this side, our wall is now following very nice and neatly along our ramp. But of course the top portion still needs to be done. Did I choose the wrong color for these? Why does that? Yeah, I did choose the wrong color. So let's finish off this top portion. So I'm going to go back to the sketch, and I'm going to call this sketch, by the way, wall outline. Okay, so there we go. Wall outline. And now I'm going to use the, where is it? The offset tool. And so I'm going to start down here by picking that, and that, and that, and that. And of course the offset's going the wrong way, so we're going to flip it around. I'm going to say 1 inch offset. And actually I want it to be 1.06 because in this case it's the height of our wall, which is 1 inch, plus the thickness of our metal. Great. And so now if I go back to this extrude, I can choose that top portion and I can remove that as well. And so there you see that we've got a nice smooth wall that follows the contour. And let me turn off the other side. And here's the thing, is this is still a sheet metal model. So for both of these, we could always go over here and we could get the flattened form. So of course that's our floor. And there's our flattened wall. I'm gonna do the right side real quick, and then I will jump back in for some other things this ramp might need. Okay, so here we are. We've got a pretty good looking ramp, right? Like, this looks like it would be pretty usable on a lot of machines, but the concerns that we still have are how are we going to attach the walls, right? Because right now these are just loose parts, and if we bent them, they would have no way of attaching together. So how are we going to attach these walls together? That's a question. Another question is if there's probably going to be a wireform that this goes into, and so how is the wireform going to attach? That's a second question. And then a third question, of course, is how are we going to actually attach this to the top of the playfield? So let's just start with that first question, which is how are we going to attach this together? Now, I mentioned at the start here that there was a decision to make as to how you wanted to do this. And the way that I've ended up doing it is you can see that the floor fits on the inside of the wall. Now, that's useful if you want the tab to stick out the side. That's usually the uglier option, in my opinion. I mean, if you want to do that, sometimes certain use cases will require that. And if that's what you want to do, that's fine. However, I'm going to change this up, and I'm going to instead have the tabs go down through the floor. Now, what that means is that the wall has to sit on top of the floor in order for that to work. I'm going to change the direction that the sheet metal model renders. You can see now it's rendering to the left. I'm going to flip it so that it renders to the right, and that will then go through the floor. Okay, so I did that for the left side, and then let me go ahead and do that for the right side. With that change in place, you can see that there's now a bit of overlap, and what happens is the wall actually comes down on top of the floor here. So there are a couple of things that we could do now. The way that I have gone about this, and from what I've observed of ramps made by commercial companies, I've seen them doing this as well, is that we can have tabs that stick through the floor, and then we just bend them during assembly. So let's go ahead and add that to this wall here. Now, for the sake of demonstration, I'm not going to do all of these. I'm just going to do a few. So let me start first by sampling this geometry here. Okay. So there we go. So we know that we're not going to need this portion, and then we know we're going to probably want to drop down below that. Let me turn off this stuff in the back so it's easier to see. So for example here, this area, the part that I have outlined, that's where our floor is going to be. And then we probably want a tab to come out. So I'm going to freehand this and then add some dimensions here in a second. And you know, something that I should have done, something that you should do, is I'm going to make a variable for metal thickness instead of typing it everywhere. I probably should have done this a while ago. Anyways, drag that up there. So now I'm going to say that my tab, the thickness is, the thickness is metal thickness, and I want it to come down 0.01, and we'll have it be the thickness of the metal thickness, and then we'll have the length of this tab will be metal thickness, actually, no, we'll have it be metal thickness times 2. Okay. And then I will bring that up there. And I will bring, what did I do there? And then I will bring this up here. Okay, so now that we've got this sketch, we want to perform two things here. One is we want to perform a remove. And so that will get rid of the excess material around it so that our tab will stick through. The other thing we want to do is now you can see we've removed the region, but our tab has disappeared. I'm going to bring this sketch back. There's another sheet metal operation here called tab. Yep, that does exactly what you think. So I'm going to choose that geometry there. And now we have a tab. So of course, this is something that you would want to do all the way up the side. You know, maybe on this one you would want 3, maybe 4. If I bring the floor back though, you can see what this is doing. So this is going to punch through the floor, and what will happen is this can get laser cut out, and then when you actually assemble this, you'll stick this tab through the slot, which we'll make in a second, and then you bend it, and that will hold the ramp in place. So let's actually work on the slot here. So I'm going to create a sketch on the bottom. So obviously here, we're going to want to make it around this. What I'm going to do is I'm going to use that. I'm going to change it to construction geometry, and then I'll do an outline all around it. And in this case, we can just have a small outline. Okay, perfect. We will remove the area in the middle there. And then the other thing that we probably want to do is we want to create another outline outside of that. And what I'll do here is I'll say half of metal thickness. All right, perfect. And then I will sample that line there. Let me trim what we've got. So here's what we're going to do. We want to start by removing. So we want to clear area for our tab to go through. So I'm going to do an extrude and remove. Great. So now you can see that our tab will fit through. But the problem is we want to, whoops, sorry. The problem is that we want to cover this other side so that it encloses it. So if I turn this back on, we're going to do that same thing where we go to add tab. I'm going to choose that there. There we go. Hide my sketch. And so now if I was to go and manufacture this, what would happen, let me turn off the left side here, is this is what the floor would look like. And then this is what my wall would look like. And then when I get them, I would just slip that in there and give that portion there a little twist, and it would hold together. Now, obviously, this could probably look nicer, right? Like, what would probably make sense here is if we added some fillets to this. So just to do a quick example here, I'll just add that there. And then maybe what we do is, you know what? I'm not going to do that. I'm going to use the fillet tool because that would be a whole lot smarter, wouldn't it? Yep, that and that. And so now we've got a nice little fillet. That looks a lot better, right? And just in case you're thinking that's going to look ugly, remember, the actual scale of this, when it gets put on the game, is going to look like that. And there's going to be posts and plastics and stuff in front of it. And if you look on production ramps, they're doing this exact same kind of thing, and it looks just fine. Okay, so I only did one, and I did it down here. But obviously, you would want to do it up the side, and you'd want to do it on the other side. Now, here's the tricky part, is how would you make this tab on this rounded section back here, right? Because this is definitely a lot more difficult. You cannot, for example, just say sketch and click on this rounded face. Now, I mentioned at the start of this video that one of the advantages when we made our outline of using a 3-point arc instead of the spline tool is that the spline tool is not recognized as a cylindrical face, but the 3-point arc is. Now, here's why that is important, is that we could draw a sketch, and because OnShape recognizes this as a cylindrical face, we could then wrap that sketch around it. So let me show you how exactly I would go about doing that. So I'm going to create a sketch here. And one of the things that we need to know is we need to know how long this, basically what is the circumference of this arc on this back part here. So I'm going to go over here to our sheet model. And you can see that as I mouse over it, I can see the regions. And so this region over here in the flattened is the same as this arc region. And all I need to do now is just to click on that, and I can see down here the length of it. If you had a more complicated ramp that had multiple, you could just select the start and the end point of the arc. So there you can see that's what I've done, start and the end point, and it's going to be the same value. I'm going to copy that value. So copy that. Now let's go back to our sketch here. And so I'm going to create that. And then I'm going to dimension the length, and I'm going to paste that value that I copied. Now, what we're looking at here in our sketch is we've got a a rectangular section, and that's going to get wrapped onto this cylindrical face. So, you know what? Why did I go back there? Let's add some stuff in now. So I'm gonna use that and complete this line all the way through. So we know that that's the portion that's going to get cut. And then let me go ahead and just add a tab over here. So this should look familiar. This is what I did on the other portion. So we'll do metal thickness. I'll do 0.01. This will be metal thickness times 2. Great. And metal thickness. All right. Perfect. Now, what we can do is we can do that same business where we're going to cut it. The trick, though, is that before we do that, we're going to want to wrap it. So I'm going to come up here to transform. It's the chevron next to transform, and I'm going to choose wrap. Now, this part is a little tricky because you can see there's solid, surface, and split. I'm going to leave it on surface for now just so you can see what this does. So tools are that's effectively the part of the sketch that I want to wrap. So let's say that I want to use all of that down there. And then the target is what I want to wrap it onto. So I can choose that. And now if you look here, I'm going to hide the sketch. If you look, you can see that it has mapped that tab onto the rounded face here, which is super awesome. However, we've only got a surface. If I change to a solid, you can see that it turns bright red. And the reason why is we're back to that same limitation of sheet metal where we cannot use new, add, or intersect. We can only use remove. And so I could, let me turn off the floor here. I could say that I want to perform a remove, and what it did there is it did perform a remove. However, I think it selected a portion that I did not want it to. So let me reselect these tools, and I'm going to leave the middle portion. There we go. So I'm going to leave the middle portion and select the parts that I want to keep. And you can see that. Ta-da! Now you may say, oh, but where's the rest of the tab? And that's a very fair question. And honestly, this is one of those challenges of modeling with sheet metal, is that sometimes you'll find yourself in situations like this, and you will need to go back and add material so that you can perform a remove. So I'm going to go back to wall outline here. And when we perform this wall outline, you can see that we're cutting to this line here. And that's going to cut off too much material. So what I'm going to do is we want to keep some of that material. I'm going to add this line here. And the distance, if you recall, was metal thickness plus 0.01 inch. So we're going to keep that amount of material. Now you can see I've kept that material. I'm going to go back here. And you can see it's already complaining that we changed our geometry. Yes, yes, we changed our geometry. So I'm going to resample that. And bring that over there. Bring that down. So now you can see we've got our geometry here. All right. And I'm going to go back to wrap. And the tools that I want to use are this portion here and this portion here. And you see how I cannot select this, like that's not grayed out. So that means that once again, our sketch is not fully closed. I see it. I'm missing that leg right there. So wrap, I'm going to choose that. I'm going to choose that. And I'm going to turn off the sketch. Now, of course, I only did one tab, but you can see here that it has in fact wrapped on that cylindrical face. So I know that that was probably a little bit roundabout, but that's just one of the things about using sheet metal. We could go and we could perform that same thing. So over here, we want to cut a hole and then have a little bit of an outline. So I'm going to project all of that, change that to construction geometry. Let's do an offset on that. We're going to offset it 0.01. Great, great. And then I'm going to do one more offset on this. Maybe we'll make that 0.02. I'm going to use that line there. Trim up this outer portion. Perfect. Perform a remove on that so that our tab can fit through. Turn the sketch back on. Perform a tab. And then add fillets. Fillet, 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 fillet. And now on a curved face, we have a tab that will slot into our floor. So if I turn off that left wall, you can see that our floor is developing. Once again, you probably would want to have maybe another 2 down here, and then maybe another 2 up here. And then, of course, you'd want to do it on the right wall. But hopefully, both of those examples give you an idea about how to do that. All right, so we've only got a few issues left. One is how the Wireform is going to mount over here to our ramp. And the second issue is how we're going to mount our ramp to the top of the playfield. So let's tackle those. Let's start first with this over here. So there's a couple of ways that you could go about this. I'm going to show you the way that will probably be frustrating, and then I'll show you how to make it easier. So the way that will probably be frustrating is that if you choose flange and you choose this edge, and you just say, I want to flange that, whoops, I want to flange that down, and then I want to cut off a portion and make it so that the Wireform fits in here. The disadvantage of this is that OnShape does not want you to make cuts in this bend right here. But the problem, of course, is then your Wireform, like that would be a drop. The ball would have to drop off into the Wireform, and that's not a nice transition. So we're going to get rid of that. And instead, what we're going to do is we're going to start by we're going to start by modeling on the top of our floor here. So I'm going to create a new sketch, press N to normalize to that sketch, and I'm going to start by drawing the center line here just to do some reference. Okay, so one way to avoid the problem of not cutting through a bend is to add a little bit of a tab and then perform the bend off of the tab. And the key is that the tab will be shorter than the entire width, and so you only bend that region. That probably sounded weird, so let me just show you what I'm talking about. I'm going to create a rectangle off of the end of our ramp here. And these dimensions don't matter because we'll trim it in a second. I'm trying to find there's the perpendicular constraint. And I want to make that perpendicular, and now I'm going to use the trim tool to cut that off. Okay, perfect. Now the distance here is important. It needs to be at least 0.09. And the reason that I know that distance is if we go back to the sheet metal model, you can see over here it says bend radius is 0.09. So that means that we have to have at least that much material in order to perform a bend. So just to keep things simple, I'm going to make it slightly longer. Okay. And here's the trick. This is the part that I was talking about, is that we don't want to use the entire thing. We only want to use part of it. So what I'm going to do is I'm going to add those 2 pieces there. And the question now is, how wide is our ball path? So when we have 2 wires that come out from it, how wide is that going to be? That's a value actually that we kind of need to know right here. So I'm going to say that our ball path is going to be just slightly over ½ an inch. Whoops. And so I want to leave enough space for that. Okay, so whoops, I dimensioned that the wrong way. Let me try that again. Let me see if I can type. Okay, there we go. 3rd time's a charm. So now we've got these pieces on the end, and what I'm going to do is I'm going to add those as a tab to our face, And now, this is the part I was talking about. Now that I just have these little bits that jut out, I can perform a flange on those. And this is the key, because now we've left this whole middle region here in order for us to slot the wireform into. So I don't know how far we're going to need this to come down. I just typed in 1/2 inch, but let's work on this next part here. So I created a sketch off of this tab, and let's sample the midpoint of our exit, and let's draw our wires. So here's where our wires are going to go. So I'm going with 1/8 inch, and we will tangent our wire to the bottom of our ramp. In other words, we expect it to slot into there. And I'm going to add a center line, and we want to say that, let's say the width of our ramp between center to center wires, sorry, the width of our ball path, why do I keep typing in the wrong thing? The width of our, wow, okay, it's late at night, I should, whatever. The width of our entire wireform is that it's going to be 0.6 of an inch from wire center to wire center. So that means it'll be half of that distance. So I'm going to use mirror and copy that over. So this is where our wires are going to go. And I'm just adding these on here as reference points. And so now what we want to do is we want to bring a tab over and under in order to support this. So I'm going to say it probably comes out a little bit here. Let's say it comes out 1/4 of an inch. And then let's say it comes down. That's probably too much. We'll say 125. That's 1/8 of an inch. Okay. All right, so that probably looks good. And then I'm going to use this, and I'm going to make it slightly bigger. So it was 125. I'm going to say it'll be 1.3. And you know what? Now that I'm looking at it, that probably is a bit too much. We'll go with 0.2. And then, of course, we want to mirror that over to the other side here, like so. All right, great. And I'm going to use both of those. Now we can use this to first of all say, let's get rid of the part that we're not using. So I'm going to perform a remove. Let's bring that sketch back. And then I'm going to add both of those as a tab. Okay, so you can see that one side added well, and the other side, we've got this weird thing going on here. Oh, and you know what I just noticed? I just noticed that I forgot to copy over that piece right there. Okay, and that's all it was. That was silly. Let's go back to what we had. 125. All right, great. So now, if I turn off this sketch, you can see that what we're left with is we have a region now that our wireform, if it's 0.6 center wire, center to center wire, it will just slot in here, and the bottom of our ramp will be used as support. And then elsewhere, we can add wire supports that will then do something. So just to show you what that looks like real quick, actually, I will sketch that out real quick so that you can see what I'm talking about. If I bring that sketch back, and what I'm going to do is I'm going to undo the construction geometry on that. Okay, great. And then let's make a new path for our wireform to follow. So what I'm doing right now is I'm drawing the path that our wireform would take. And so we'll say 3-point arc. And yes, okay, perfect. So maybe something like that. I'm just kind of making this up, by the way. Okay. So, because I just want to describe what I mean by this, I'm going to use sweep, and I'm going to select those portions, and then I'm going to select this line. Great. So now we've got our wireform. And here's the thing that I was trying to describe, is when this wireform gets stuck into the ramp, what we are likely going to do is this right here. Whoops. So the Wireform will slot through those little holder tabs, and pushing against the top of the ramp will add pressure. And elsewhere, there will be some kind of mount that actually holds this up, but this should be sufficient to hold it in place. Future neon blue here. Something that I should have mentioned is you also may want to consider making a transition from this flat portion of the ramp into the Wireform. And one such way of doing that is we can just create a sketch here on this floor and add a triangular cut like this. What this will do is it will help the ball transition and drop down into the Wireform without as much of a clunk, because as the ball rolls into the triangle, it will slowly descend. So we've resolved now. We've got how our ramp is going to, the walls and the floors are going to attach. We've got how our ramp is going to attach to our Wireform. And so the last piece now, I'm going to turn those off because we don't need them. The last piece now is how our ramp is going to attach to our playfield. So this one, hopefully by this point, this should be getting a little easier. Say that we've got some kind of hex support. Well, you probably can guess. All we need to do is I created a sketch on this upper area here. And what we could do here is we could say, I'm going to just create another region here. You know, you would need to know where you're going to support this, but we'll say that we'll add a hole here to screw a hex support into. So I've gone ahead and modeled the round portion, and I'm just going to create 2 lines on the side that connect to that geometry there, and then I'm going to use tangent and tangent, and of course you would want to measure a lot of this out so that it matches your playfield. But I'm just doing a demonstration, and I'm going to trim off these other pieces. Perfect, perfect. And then I'm going to say add tab. Great. I'm going to turn that on, and I'm going to use the holes tool. And in this case, let's say that it's going to go through a number 6, like a 632. I can just add a number 6 hole there. And maybe to make that look a little nicer, I can add a fillet. Yeah, something like that. So now on the back of my ramp here, if I turn off my wall, you can see that that would be a portion that we cut out. And then of course, when it gets mounted on the playfield, you know, maybe there's a, actually, I'll just go ahead and sketch it. Maybe there's like a hex spacer that comes out of this. Maybe something like this. Yep. And we got a variable for our ramp height. Yeah. So, you know, maybe you've got this mounted on a post or something of that sort. And then you've just got a hex spacer to keep it up on the back. That's certainly one approach. That keeps it up in the back. With the mount in the back taken care of, let's turn our attention to the front. Now there's a few ways that this could go, but actually let me turn off the wireforms here. Whoops, what did I do there? So that one and that one. So there's a few ways that this could go, but the way that I've seen this done on most professional ramps is that they add a flange that comes out the front. So I'm going to pick flange from up here, as I have in the past, and we'll select that bottom edge. And you see now that it kind of looks like it's blocking the ramp, and we could just take a guess at what that is, but let me show you how to properly do this. So way back here at the start, when we drew our profile, remember that is the, whoops, I'm getting all turned around. So that is the side view of our ramp. When we did this, there is an angle between these two. You just saw me remove it. I'm going to add it back. So that value there. Now, the way that math works is because we want this line to be parallel with the slope of a ramp, we could just copy that angle and paste it, and it would be fine. In fact, let me show you that. We're going to come back and change this, but I just copied that angle, And I'm going to jump over here to flange, and I'm going to paste in that angle, and you can see that it is perfectly flat. The problem that we may face, though, is when we go to actually produce this ramp, most online services that do bending will not do a weird angle like that. So we can make a few adjustments here. I'm gonna delete that angle. So in terms of constraints, let's say that we wanted that to be an even angle, and I put this back, but I typed in 24. You see the entire thing here goes red. And that's because we can either set this angle or we can set this fixed height. We can't do both. So for example, in this case, you see if I delete the dimension on the height, now it works out perfectly fine. And here you can see that my height is slightly different. So all I'm going to do is I'm just going to switch which value I copy. So I'm going to copy that length value there. And now we've got this nice 24 degrees. I'm going to go up here to my ramp height, and I'm going to paste in that value. And this is an advantage of using variables. In fact, as a CAD designer, I feel like I should use variables more often than I do. But let me roll forward here, and actually let's add a variable for the ramp angle. So we'll call this ramp incline, and that's going to be 24 degrees. Put it up here at the top on our profile. I'll stick that in. Ramp incline, perfect, 24. And now over here on our mounting flange here, we could say ramp incline. All right. So now we have it at an angle that is a whole number and can actually be professionally bent if we were going to have this manufactured. Now, another thing here is you saw at the start that I just dropped the flange right along the entire front entrance. However, more often than not, what actually happens is we might want to trim a little bit off of the ends here. So on that corner there and on that corner there. And in order to do that, we can use a trick much like we did up here, where instead of just dropping the flange on the edge, we can do some editing work on this part up here to minimize the amount of flange width that we have, because OnShape does not let you do a remove on a bend. So I'm going to step back in history. I can just roll this back, and what I'm going to do is I'm going to create a sketch on the top of the floor here, and let's just cut away some of this material. So let me turn off the walls. So I'm just going to draw a circle here, and let's say that this will be something like that. Maybe it'll be 3/4 of an inch, and then I'll do one on the other side. And then I can remove that area. So now I've shortened that a little bit. And now if I pull forward in history for the flange, you can see we've got a little bit of a shorter area there, and our walls come down just like they should. Now this can be useful if you're planning on adding other features over here, maybe a post or a target, or even those nubs of death that go on the side. All of those, you're probably going to want a shorter mounting flange on the front, and that's how you do that. Now I'm noticing here that my flange is a little long, so let's shorten that down a little bit. That's probably about right. All right, so with the flange in place now, one of the next concerns we have is how are we actually going to attach this flange to the playfield of the game? This is where choice of hardware starts to become a bit more relevant. And let me jump over here actually to Marco's. So of course, the area of the top of the screw or the bolt that you use is important. And there is a special type of hardware called a PEM stud. Here's a few examples up here. This is at Marco's Specialties. But here's a few examples that you can use. And you can see here the advantage is, if I zoom in on this one, you can see that it's got these little grooved ridges that are going to grip up at the top, except it has a completely flat top that almost doesn't even add any vertical area. And this is the kind of thing that I think is useful for mounting ramps. So for our case, let's just pick one here. Yeah, let's say that we were going to go with this one. So this is 1032 by 7/8 of an inch. So that has enough thickness to go through our ramp and through the playfield. 1032, so that tells us the size. So let me jump back over here and let's create a sketch here up on this plane. And we know it's going to be number 10 in size. So let me just add here a couple of points. Okay, this is going to be our mirror line. I want these to be the same. Mirrored over there. All right, and then let's just say it's 0.2. So now that we know our hardware size, we can add the corresponding hole. So there, and I'll say this is a number 10. All right, perfect. Now looking at that, I may have made this cutaway up here on the top slightly too big. So I'm going to go back and just make those maybe a little bit smaller. We'll do 0.6. All right, let's see how that looks. Okay, yeah, I think that looks good. And maybe we'll add a fillet here on the corner. Perfect. So we can use the PEM studs, and those will go down through our playfield and mount on the top. And then typically from here, you would have a flap over top of this ramp that would cover up this area and make a nice transition. So let's just draw that in. I'm going to turn off my left wall here, and let's turn the planes back on. And in this case, this was the plane. Yeah, that's the plane that bisects our ramp. So let me go ahead and add a sketch on that. Turn the planes off. That hotkey is P, by the way. P will toggle planes on and off. So let's go ahead and draw one out here. And I think, where am I at? So I'm just looking at where some of these pieces are. I want to avoid that hole a little bit. So I'll probably start about there. And now I can draw out a little bit of a length here. I want to make this parallel to the top. And this distance, so spring steel is typically 0.015 thick. And in this case, I want it to come just up to where our first slot is. So that's why I am projecting that dot. So I will make that coincident. And then want something to come out here, down here on the bottom. I'm just going to kind of eyeball something there. And that will be 0.15. Okay, perfect. And it probably will have a lot more of a bend in it like that. And then let's add an arc in here. All right. So that's probably about the area that our slot would occupy. Did I say slot? I meant flap. That's the area our flap will occupy. And then let me just select that here. And our thickness there is set, but I want that to be symmetrical. And probably that looks too much. Whoops. Decimal points are important, kids. Yeah, so that's probably, I'm just kind of eyeballing this. What I'm looking for here is I'm making sure that we're not running into the wall on either side. All right, so that looks reasonable. There's two more things we still need to do. One is we need to add holes where the rivets will go through to attach to the floor of our ramp. And then secondly, we may want to give ourselves a little bit of access to actually put the PEM bolts in. So let's take care of that. And you know what, looking at this, I don't think I gave myself enough room right there. So let's go back and fix that real quick. So where is my, there it is. Here's my sketch here. Just gonna bring that down and give myself a little bit more room here. That's probably good. Okay, so let's create a sketch plane that we're going to use to draw on what's happening here. And I'm going to start by adding the point where this is where we're going to add a hole for the rivet that will rivet through the ramp. So there we go. And let me add a mirror line here. And we'll mirror that over. Perfect. Now the other thing is we want to add some access for this part here. Yeah, for that part there. And so what I will do is, let's just make that 1/4 of an inch. You've seen me do this before, so hopefully this is old hat by this point. I'm just going to draw 2 lines that I then make tangent to that circle. All right, perfect. And then we're going to use the trim tool, trim, 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 trim. Didn't want to do that last one. And then, of course, mirror it over and enclose the one on the right. Okay, so now we can add the hole for our rivet. That is way too big. That is, should be 1/8 of an inch, since that's how large the hollow rivets are. Now, one thing you can see here, the CAD program automatically selected cutting through the ramp, but if it didn't, so you can see here floor and part 7. Let's say that it was only cutting through the flap here, and it wasn't cutting through. What you can do is you can click on merge scope and then just also choose the ramp as well. So then you get that in the same spot. And then let's turn that sketch back on and let's perform a remove operation. And the merge scope here will be the flap. So now we have a custom flap to rivet and make a transition into our ramp. We maybe want to add some fillets on this, so let me go ahead and add some in, because that was looking a little sharp. So we'll put one there, and we'll put one there. Great. Would it look better if it was slightly bigger? Yeah, sure. Now, the other thing that I'm noticing here too is this part here may be cut in a little bit too much. So we could go back and we can adjust that. And that was up here. I know I keep tweaking around with this one. The challenge here, of course, is that you want to leave yourself enough room to put other features like posts or nubs of death without making it too small. Let's see what this looks like. All right, yeah, that doesn't look too bad. I could probably further improve that by making this a little bit closer, and that will shorten that up even more. Okay, yeah, I think that looks good. All right, so there we go. Let me turn off that origin. Yeah, so there's our demo ramp, which I don't know, it looks pretty legit, doesn't it? Let's go ahead and take a look at uploading this into SendCutSend. So because our ramp is a sheet metal model, there's a couple of things that we could do. One is that we can bring this out and we can export the flattened version of it. So let me go ahead and do that. So I'm going to say export to DXF millimeters. All right, it looks great. And now over here in SendCutSend, I can choose that file and upload it. Now, there's a few problems that you may encounter with SendCutSend, and I run into this quite a lot. The first one is this, which is you can see here, it says that the DXF file that we have uploaded, the geometry doesn't completely touch. So you can see in their illustration, it's not completely enclosed. And this is super annoying, and this is just an artifact of OnShape. Sorry, but there is a workaround. So let's go back here, and I'm going to delete that DXF file. We can, instead of exporting this version over here, we can actually export the entire part as a step file. So here you can see step right here. We can export that, and then, whoops, I did not mean to close that. So let's export that. And it doesn't happen instantly. It'll take it a second. And then what'll happen is you'll see a download thing appear over here. Anyways, let's go ahead and upload that. So I'm going to upload the step file. They're a little bit larger. They are a 3-dimensional file. And this is a lot more compatible with SendCutSend, as you can see here. So nice. Yes, that is the part that we want. You can see there's 2 options. We could machine this out of a huge block of billet aluminum, which would be incredibly expensive. So I'm not going to choose that option, or we can laser cut it out of sheet metal. Now you notice that when I did that, it just did something that was kind of important. So actually, let me go back. So here we're looking at the model that we uploaded, and you can see here that there's this smooth arc right here. However, as soon as I go into sheet metal, you can see that it re-renders it, and whoops, what's it doing? It's stuck on my cursor. You can see that what happens is it re-renders it, and it replaces that smooth arc with a bend. So we definitely don't want this because we want this portion to be a smooth bend. We're going to have to do that ourselves, so we'll turn that off. So let's go ahead and choose our metal. So we'll say stainless steel 304.6. Great. And now here we get to the bends, and we see there's a few things going on here. So we've got some issues with minimum flange, which we can go back and address. And then this is the thing I was talking about. So we definitely don't want this. So if you don't want to bend, you can just clear it out by doing 0. We'll do that bend on our own. Let's address these other issues. So these down here, I believe I commented on these already, which is in order to bend, the machine has to have enough of the material to grab in order to hold it while the bend happens, and this portion here is too small. So in fact, if we click on it, it'll tell us, you can see here, it has to be at least that big. So let's fix this, and then we'll fix the other one. So that's over here. So we're talking about that part right there. And I think, yeah, okay, cool. So that's where we're at. And it said the minimum was 0.255. So I'll make it 0.256 just to be on the safe side. Okay, great. It added a little bit of depth there, but it's not too bad. And actually, you know what? Looking at it, I think this would probably look nicer if we added some fillets. And we'll give it a 1/16 of an inch radius. Yeah, that looks better. All right, well, I had to cut and problem solve there for a little bit. I moved a whole bunch of stuff around, and this is a thing that can happen with SendCutSend where it will be really particular about some of your bends. So over here, what ended up happening is originally we had the bend coming out here, and I ended up having to add this distance here, which you can see is their minimum distance. What I think it was doing is here we've got this arc that goes around the backside, and it was counting this as not being the full width of the flange. And so because this kind of cuts over into it, it was saying that it didn't have enough space to hold it. So the solution is I just added a little extra length there, which you can see is their minimum distance, to give it enough space to hold it. And down here, same thing. I ended up just moving around some of the rivet holes and the mounting positions until it was happy. Sometimes what it does is it will take distances like the edge of the circle to the edge of the flange, and you can see that's a much shorter distance than it allows. Sometimes it'll take that and think that that's how big the flange is. It can't decide the difference between the flange and a hole that you've cut in the flange, and if you just move things around, sometimes it'll cause it to read it correctly. So anyways, now that I've got this updated, we can jump over here to SendCutSend, sheet metal, metals, stainless, 304.6. You can see now all 4 bends are doing just fine. They're telling us that we're going to have a little bit of deformation. Yeah, that's fine. Whatever. Okay. The one thing that we have to be careful of here, though, is this one. We want to turn that off, so I'm going to set that to 0 because we're going to do that ourselves. And, yep, perfect. And with this, we now have a ramp that's ready for manufacturing. We can choose any of our finishing options, like if we wanted to get it powder-coated bright yellow. If you're doing a submarine theme, there you go. Anyways, that is it. Hopefully that was useful. That is the I tried to have the complete process of doing an entire ramp from start to finish. If you got questions, you can hit me up on Discord or potentially post a comment below. Thanks, everyone.